Okay, and question 10. That's us, getting through the paper now. I hope you've seen that there's a lot of really doable questions in here. Nothing to be scared of. If you just take your time and you think about what topic you're doing, there's lots of good points to be had. And this is an excellent, straightforward. We should really know our polynomials. So an excellent chance to get some marks. So show that that is a factor. Okay. So when we're doing this, it's synthetic division. And we make sure that we write our coefficients. So I've got my 3, 10, 1, -8, and -6. And you have to make sure if there's a gap there, so say there was no cube term, I'd have to put a 0 here. Okay, so make sure, even if there's not a term, it's represented in your division. Likewise, if there was no unit, I'd still have to put a 0 in here. Okay, so be careful for that. And we are hoping that if that's a factor, the remainder is going to come out as equal to 0. So therefore, x plus 3 is a factor. That's what we should have for this one. Sometimes it tells you that the remainder is whatever it is when you put something in. But in this case, if it's a factor, then the remainder is equal to 0. And you know what? I'm actually just going to be really pernickety, and I'm just going to write the word remainder. Okay. There we go. So let's crack on. So the first thing I do is I change the sign. The -3 goes in here. And that's because we literally put the roots in. Okay, it's the roots that we put into this equation. And then I'm going to pull this down here, and we're ready to start. So we're multiplying this way and adding up and down. So multiply diagonally, -3 times 3, and then we add, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply. Ta-da! So fantastic. That's 2 marks right away. If you think on that, that's pretty awesome. 2 out of the 7 for just doing that. Really good. And now hence I factorise fully. Okay, so if I'm factorising fully, I need to keep doing this process. So I know I've got this factor in the bag. That's good. But I need to go again. So this effectively comes out as x plus 3. And this is 3x cubed plus x squared, take away 2x, take away 2. That's what this bit symbolises. So I don't need to put that up over here. So 3, 1, -2, and -2. And try again until I get another 0 in there. Now, which number should I put in? Well, the number, they're not going to be mean to you, okay? I would start at 1, -1, 2, -2, and eventually you should get something. But make sure the number you put in is a factor of this. So if this was a 5, I wouldn't be putting 2 in, I'd be putting 1 and 5 in here. If this was a 7, I'd be putting 1 and 7 in. But usually they give you a 2 and a 3, and you're going to be putting in 1 or 2. Okay, so I am going to have a look at the marking scheme to save me a little bit of time and just check one. So I should be able to put 1 in, and that should come out okay. So yeah, see, they're not that mean to you. Do you know what I mean? They're not that mean. So I'm going to put 1 in. But yeah, the point is, don't start at 10, right? Do 1, -1, 2, -2, and eventually you'll be okay. So let's bring that down. So 3 times the 1, add it, multiply it, add it, and multiply it. Fantastic. So I know that x take away 1 is then also a factor. So that's really good. So I've got x take away 1. I've got x plus 3 from before, and this bit is now going to be squared. So that's 3x squared plus 4x plus 2. Fantastic. Factorised. And now I'm thinking, can I factorise this any further? Well, I don't need to do synthetic division. I can just do my polynomials, can I? So does something add to 4 and multiply to 6? So 6 and 1 and 3 and 2. No, nothing actually works for that one. Right, okay, so that's not very good. So let's have a think. What is the nature of roots for that section? So if I was saying that this was, let's see, so usually it'd be a nice easy factorise, but this one's a bit trickier. It's wanting you to use your b squared minus 4ac. So b squared minus 4ac. So that's 4 squared. Take away 4 times 3 times 2. b squared minus 4ac. So 16 take away 24. So that's going to be equal to -8. Okay, so -8 is less than 0. So therefore, there's no real roots, is there? No real roots for this trinomial. So my final answer then, factorise it fully, would be y is equal to x, take away 1, x plus 3, 3x squared plus 4x plus 2, and that's you. Okay. Usually it pans out slightly differently here, where you would just use your trigonometric, your trinomial skills to factorise that further, but we can't factorise that, and you just need this proof to say that you can't factorise it. Okay, so a nice little question actually, and the proof's in the pudding there. If you started this question off at B, you'd be looking at that going, well, there's no way I've got 5 marks for this. So you're actually getting a few marks for understanding that as well. So really quite nice actually, quite good. So yeah, polynomials, get that in the bag. Obviously these are not your solutions. If it asked you to solve, you would put it equal to 0 and work out that x is 1, x is -3, and you can't solve that. Okay, so just watch out for when asked the difference between factorising, put in the brackets, and solving, where you actually take it to that final step. Okay, and yeah, question 10, all done.